In this video, we're going to look at another example of separation of variables. This time, we're going to look at Schrödinger's equation. Now, this looks really complicated. Trust me, when I first did it, I remember looking at that and being terrified. But it is a one-dimensional equation, and it looks bad because it has all those fancy symbols and whatnot. Right? But it's really not that bad. It's really not that bad. So let me go ahead and rewrite what they have there. And they give us the answer. It's really not bad. What in God's name is that? Is that a tau? Oh, it's psi. Yeah, it's psi. So that psi is this one. Okay, yeah, that's psi. Of xt plus v of x psi of xt is equal to, what is on that h? What is that? Well, it is what it is, you know? We'll just treat it, I think it's a line. T times psi of xt. Yeah. So this is pros psi of xt is equal to x little x t little t, and show that x and t satisfy the ODEs, and they give us the answers. So first thing is first. Let me think about this. Let's substitute, right? Let's substitute. So we have minus h squared over 2m times squared over dx squared times x. Oh, is that just xt? Yeah, x. Excuse me. Well, that'll be x double prime, right? Oh, it's the part. It's okay. So think of it like this. This is separate from that. Think of the second partial with respect to x of this. That would be x double prime, or as they have it written in the answer here, or it can be written as this of x, right? Yeah, and then the t of t is in there. It's the same thing. Plus v of x times, same thing, xt. I'm going to remove that x of x. It's just x, and it's just t. That's an x, not a time symbol, is equal to weird h t prime, because it's the first derivative of t. So I guess they put the dt, yeah, d dt of t. Yeah, okay, that's weird. But anyways, we divide everything by xt. That leaves us with this. This is just a constant, right? You can kind of just treat that and that as a constant. As you see, this isn't really that bad. Sorry, this. Where did this come from? This is. Oh yeah. This is one term. I'm going to group this together. Times t, so that goes away, and we're left with over x, plus v of x times xt, which is nothing, so that's I, weird h, d dt t, so that's d dt. There's supposed to be an x there, right? Yeah, I forgot the x. Over t. So then we add our separation constant. I'm just going to copy. I'm not writing that again. We add our separation constant. Then after we do that, well, we have one of our equations, I weird h times d dt of t minus lambda tau is equal to 0. Yeah, oh, they keep that on the other side. Right, so that's one equation. And then we have the other one. Multiply everything by x. We have d squared dx squared times x plus v of x times x is equal to lambda x. Yeah, that's it. See, not too bad at all. So that's how you separate separate variables, right? Remember my last video, I did one where we had 3 variables, so we had 3 ODEs. So if you missed that one, go back and watch that one because that's a good example. Next off, I believe we are looking at give me 1 second, I forget the next step. Oh yeah, we're going to take a first look at boundary value problems, and we're going to look at how to find the eigenvalues and eigenfunctions. So I will see you for boundary value problems.